Good afternoon, everybody. I hope everyone's having a good time at the show. Today we're going through accessing hardware-accelerated video codecs on Android, specifically on Snapdragon chipsets. So our agenda today, we're going to go through a quick overview of basically the playing field on Android, requirements for what this presentation is about, what OpenMax and iOMX are, how to build this, how to integrate it into your own application, and then finally some time for Q&A. So right now with Android, the beauty of the way the Android operating system works is that Android allows developers to work over a wide breadth of devices using the same operating system. But what we want to access is the depth. We want to go into specific hardware features that are on different chipsets, and today we're going to talk about the Snapdragon chipset and being able to access the hardware accelerated GPU using video codecs. Now, the issue with now is that with general Android software programming for video, then you're taxing the CPU and it causes your video performance to suffer with slower frame rates, a little choppier, and by using the CPU a lot, it drains the battery more. And on our Snapdragon chipset, our GPU offloads a lot of that processing. And the question is, how are we going to access that using Android when they don't directly give us those types of hooks? So in order to do this, we're going to need specific Qualcomm hardware, a device with a Snapdragon chipset. For what we're talking about today, the 8X55 is the ideal device. And what we're talking about is applicable in some instances to 7X30 and or 7X30 as well. But 8X60 then it's still in early phase. An SD card is ideal to be able to hold all the space for what we're doing. We're going to be decoding some video files into YUV format, which is a very large file size. So an SD card is preferable because the amount of onboard memory can be limited. And what we're talking about today uses Android Froyo 2.2, as Google introduced some new APIs under the hood with 2.2 that we'll be talking about. If you have a device that has read-write access or rooted, it's also preferable so that you can access some of this stuff directly on the device without having to integrate it into an APK. And additionally, when you're going to be using software the way that we've designed it, then you're going to need a PC that can build Android from source. And many of you developers may be familiar with just taking the Android SDK, downloading it, and building your applications that way, but there's some shared libraries we'll need to build from source, so you'll need a machine that can handle this. And if you have Android application development as a background, then of course that's a plus. And if you know OpenMax IL, how many of you are familiar with OpenMax? Okay. Then this is a set of APIs that we'll be using. So I'll go over OpenMax IL briefly. Now, many of you are familiar with OpenGL, I assume. And the concept is lots of different graphics hardware. With OpenGL, then you have a common API interface that lets you target all those different graphics hardware using a common set of APIs. Well, the Kronos group has developed OpenMax, which does the same kind of idea, but for video. And it's, for those of you completely unfamiliar with OpenMax, it's generally like a black box. You pass it a series of buffers. If you pass it buffers that are full of encoded data or decoded data, and out the other end comes out the buffers that you've, if you pass it buffers full of data, then you get those buffers back as empty, so you can refill those and fuel them back into the component. And on the other side, you also get the output, which is encoded or decoded data, whichever you prefer. It's very simple, and that's what we'll be using today to access this. iOMX is it's basically a wrapper to OpenMax IL, and Google introduced this with Froyo and Stagefright. So some of the classes will be abstracted into iOMX to make the calls easier. Gingerbread also allows you to access this system. So under the hood, basically what we're doing with the sample code is we're instantiating an OpenMax IL component handler, where we're querying the device hardware and asking it for specific components. So if you need like an AVC decoder, then we have a string that's a Qualcomm OpenMax decoder, and we're requesting the hardware asking, do you have this component? If you do, please instantiate it and bring me a handle to it. And we also have to derive from an observer class. And so what happens is we pass the buffers of information to this decoder or encoder, and the observer in another thread will come back and respond when it's done processing whatever piece of data we've given it. And so all you need to do is, once you have that component, you configure the input and output parameters, and you can feed it from a thread, feed a file in, or however you want to feed the component. It can be from a stream. And for our sample code, we've done a very base case of input and output file. We pass it an encoded file or a decoded file, and we get the opposite on the other end. So when you want to do this on your own for integration into your own application, then you'll be instantiating the encoder or decoder by requesting the component like we discussed, configuring it, and through our sample code, we have a new set of sample code where you can pass it callbacks to an output handler. So once you get let's say you're decoding a file, then when you get the decoded data out, then you can pipe it to a file, you can pipe it to a stream, pipe it to your video screen, what have you, and also an input callback. So input callback's a little different, the way we've designed it. Then you need an empty buffer that you can pass data to the component with. And the callback will let you know when a buffer is available for you. Let's say there's 12 buffers, and you want to keep passing it information. Once it's full, then you have to wait for a new buffer to come back. Instead of having you sleep, then we have a callback letting you know when that buffer is available. And you just need to initialize the component, which gets it in an execution state, feed it with the data, and when you're done, you signal completion, so the component knows that when it's going to be done accepting data. And so when on the back end, when it's done receiving data, it can notify you saying, I'm completely done, and then at that point you can deinitialize the component. So a new sample code was released this week, and it has minimal latency compared to the sample code that was previously up, and the stability is improved. We have the callbacks I discussed, and we had a sample code up back in February, and that was a good guide for being able to reference what we've done and be able to replicate that in your own code. But what we found is that developers, after running the sample code as is, like to take whole pieces of the sample code and attach it to their own code and integrate that way. So we've debugged the code and made it a lot more streamlined, taken out all the sleeps, improved a lot of the stability, and allowed for custom integration using the input and output callbacks. So now you can use it out of the box and then optimize it and refine it as you would for your own needs. So as far as building and running, there's two ways of using the sample code. One of them, there's an APK that you can download to your device, and any commercial handset that can run this code then requires no modification. You can just throw it on your device. If you have an SD card, it'll read and write to and from the SD card the encoded and decoded files. And it's all integrated via a shared library, which we'll go into later. And there's also a command line version of the executable. So what you can do is you ADB shell and push the executable to your device. And this is you may need root access for this. And you can, without having to go through the library building and exporting and NDK, then you can immediately take this application and run it with say I want to decode from this file to this file, and you can see it right there on the device. Great for debugging because then you reduce the number of points of failure as you're developing. So the Snapdragon MDP is available on our website, and what's on Qualcomm's website, excuse me. And what's nice about that, it has official root access. So it's also, in some cases, there's pre-release Qualcomm hardware, and you can test all this stuff on the device without having to root your own device and being able to optimize to early release Qualcomm hardware. And there's a session at 2:30 p.m. in Elizabeth F. of leveraging the Snapdragon 8660 MDP for app development that I encourage you guys to go to. So as far as building, you're going to need to download an entire Android source tree. Some of you may already have this. And there are certain Qualcomm-specific files you'll need to download as well. This is all in the guide that accompanies the sample code. And once you build the Android source, then you can output either an executable or a shared library, or both, depending on how you write the code. The sample itself already is prepared to be able to do both of those for you. And if you want to integrate into an APK, then you'll need to export the shared library and create the bindings from Java to C, and then you'll need to build the NDK shared library using the NDK, write to the Java bindings, and from there then your application can use the sample code directly. And a full example is available in the sample code. I encourage you to look at it. Yeah, so the sample code again, at this point in time, does not show you how to directly integrate with the screen or the camera. It's just basically the file I/O. It's an example for you to understand how the encoder or decoder works. What's really nice about it is you just need to query the device and ask it if it has a particular codec you're looking for. And if it doesn't have the Qualcomm codec, it'll return as a fail, and you can go ahead and use the software encoding or decoding as a backup. So this can run on all commercial devices in that fashion. So here's just a little preview of how some of the integration works with the sample code as it exists on the website right now. We did this all in C, so you don't, if you want to write it completely in C, you don't need to have any of the classes in there. And there's the initialization and deinitialization. If you want to get the last error after you run any of these commands, then you can use OMX interface error to get that error code. There's a way you can get the result description if you want a human-readable result. For the decoder, you can set the input packing format or the compression format, depending on what type of decoder you're working with. And then for feeding the component, then there's just very simple send input data, and you can pass it the buffer and the size of the buffer, and an end of input flag to let the encoder know or decoder know that you're done sending data to it. So again, as I discussed earlier, if you send input data and there's no available buffers, then it'll just fail, and it will give you a particular error code you can check for. And then if you wait for the callback to come, and you can use that to try to acquire another input buffer to feed more data into it. And again, handle output data is one way for the output integration. It's that lets you choose how you want to work with the data once it comes out on the back end. So again, this is all online on developer.qualcomm.com/tools, and it's under video codec sample. This is just an introductory right now to let you know how to get into it. You can see more on our website. And if you're unfamiliar with OpenMax IL, it's a very valuable resource over on Kronos.org. I encourage you to look at that as well. So at this time, I'd like to open it up to Q&A. Sir. I'm sorry, I can't hear you too well. Oh, I believe the question was you'd like to see some examples of the Java bindings. Right, that's on the Java sample code. I can, if you download that, I can walk you through it shortly here in the next 10 minutes or so, after the Q&A is over. Any other questions right now? Sir.
Do you have fallbacks, software codecs from your hardware codecs, or being locked by others?
We don't have those in our sample code, as we're only showing you the hardware side, but we can, through the sample code, you can see how you can query and find out if the hardware is available. And then you can rely on your own software codec fallbacks. The question was, are there performance metrics between the software and the hardware? And Rakesh, just well, would you like to speak to that?
With software, you can do only HPGA. You cannot do more than HPGA resolution, but with hardware, you can do up to, on 7x30, you can do 720p, on 1080p, you can do, on 8660, you can do 1080p. And the performance is less than 30% CPU for hardware codecs. For software codecs, it's depends what you try to do, but for hardware codecs, on all the resolution less than 1080p, it is just less than 30% of CPU. For software, it is, for HVGA itself, it can go up to 60%, 70%. Yeah, it's because it's done in ARM. Everything is done in ARM, and particularly for encoding, it takes a lot of CPU cycles to do it.
Yeah.
Yeah. Okay. Thank you, Rakesh.
It's fine. Like, just like that.
It's a small. Sorry?
Next time you can answer.
Okay. Recommendations for getting the decoder to the screen, then Rakesh, correct me if I'm wrong, that's through the renderer, through iOMX renderer?
So you can use surfaces in the Android, which is provided by the surface flinger, right? You can create a surface, and then when you create a surface, you can ask that I want to use this particular color format, which you get from the decoder. Open with that surface, and then in the surface API, there's a method to pass the buffer with the FD and offset, right? You just pass that, and then you can do that. Alternative mechanism is to use overlays. You can use overlay on 7x30 and x55 devices. With Gingerbread, in Honeycomb, there's no overlay, right? It's just based on the surfaces. You can use surfaces. Yeah, and we have a mechanism to register the buffers for the surfaces.
Yes, so the recommendation is Surface Flinger.
It's depend, right? What is your use case? You can go with any of the given approach. You can see the look into the code on base, frameworks, media, live stage fried, / render, and then you can see the code there. You can look into the awesomeplayer.cpp file. Inside that, you can look into the house of how the render has been created and been used. You can use the same approach for your.
And we'll be working on a sample code update in the coming months to show how to use the decoder directly to the surface.
In Honeycomb, there's architecture change, so they use native Windows, so we need to come up with a new solution to that. So we will just wait and watch, and then we will create it. As of now, you can do just a mem copy also, right? So mem copy to a heap buffer, just do that of the output decoder buffer. It should be fine.
Should I wrap it up?
Yep.
Okay. Great. So if there's no other questions, then Rakesh and I can meet anyone else for additional questions over in the lounge area. So thank you for coming.
Yeah, thank you, everyone.
Thanks.